So I have been sent this rather sensational looking logic board out of a Mac Classic, and as you can probably observe, it has suffered from death by Maxell. The battery has exploded and leaked its corrosive funk all over the board, and you can see all of that rust and corrosion going on there. Now it is my plan to try and resurrect this board and bring it back to life. So my plan will be to obviously remove all of that corroded gunk around the battery holder there, replace the battery holder. I think some of these components around here will probably need to be cleaned up a little bit. We've lost our little Y1 crystal oscillator. I still have it, but the pins have just rusted right through. But they're relatively easy to replace. It's all pretty much up this end here. The rest of the board doesn't look too bad. So I'm hoping that after a little bit of a clean and a little bit of TLC, I'll be able to turn this into a fully functional board. So the next step will be to get it under the microscope and see just how bad it is. So we're now looking at this this same board under the microscope, and as you can see, the biggest area of problem is around this chip here. We've got all this lovely green chunky corrosion going on, and the majority of that is all going to clean off for sure, but it's just a question of what state those pins are going to be in once it comes off. Are they going to still be connected, or are they actually going to be broken in half? So we will see, but I'm not going to muck around with that. We've also got a couple of, I think there's a diodes here that look like they could be a problem. And we'll see. Once again, once the cleaning comes off, and I'll probably have to remove these and put them back on again. It's just a question of whether I can clean them up enough, and of course the question of whether they still work too. I'm just trying to get a little look-see at this one, because I do have a few spares of these sorts of components, and I may actually have this one, and I may be able to just put on a new one, which would be nice. I may end up having to put a new one on anyway, but it's just a question of whether it's something that I have already, or whether it's something that I'm going to have to order in. Lovely. Coming off, there we go, he's coming off, hey, look at that. Big bit of gunk coming off there. And then, what is that, 5 DK? What do you reckon, 5 DK? Maybe. Okay, so anyhow, the first thing I'm going to do is get this off the old battery holder. I'm going to do this and hopefully do as little damage as possible during the process, and I'm going to sort of break it off, and then see what the state of these traces underneath it are. You know, the hope is that most of this stuff is just sitting on top and it hasn't corroded right through into it. Look at that little network of something. Crystalline. Look at the little... That is just the most amazing thing I've ever seen. Maybe I don't see enough amazing things. Okay, look at the wonderful little crystal formation going on there. So I don't know if this is a common occurrence on boards with leaky batteries, but that is really quite beautiful. There's a little one just there. Yeah, absolutely gorgeous. Incredible. So, okay, well that's enough sightseeing. Now we're going to have to get going. And look at what's the state of these legs here. Now, I don't think this is an important chip. Oh no, just the CPU. Okay, well, look, at the moment it looks absolutely horrendous, but of course that is likely to change after it's been cleaned. Okay, so I've taken the battery holder off. This is where it used to be, and that there is the positive end of it, and that is the negative end of it. Now, the thing that is really causing me concern at this stage is the state of these vias here. And you can see the level of corrosion that's there, and the concern is that corrosion goes right through and we might end up with a short between different layers of this board. Same goes here. This is obviously the positive. Now, I can restore this trace, that's no problem, but you know, this is a via that goes through to the other side, and who knows, it may even do something in between layers, and it is just ugly. Look at that. Just shocking. Now, I've also got a resistor here with half it missing, and even I've got a trace missing there as well. I can rejoin it to this via here, that's fine, but once again, look at the state of that via. It is just shocking. Look at this guy here. I don't even know what's under that. The resistor? Yeah, we go. Same sort of resistor as that, but this one here, this one felt special and decided to go orange, whereas this one went white. So this is the special one because he's orange. Now, I will probably be able to find replacement parts for these on some of my other boards, so I'm not too fussed about that, but I can't really do anything. Well, I shouldn't say I can't do anything. I can, you know, we'll see. Once I know a little bit more, these little solder balls are my doing. As you can see, this solder here is just super old, crunchy yuck. And when I applied a bit of heat to it, it just started pushing little beads out. That's all going to have to be replaced. All the solder there, all those components are going to have to come off, pads get cleaned, and the components go back down again. And, oh, who knows. Just a lot of work for a Classic, isn't it? Far out. It's very atypical to have this level of damage on this side of the board. I mean, normally when I see these things that have got corrosion on them, this side is pristine, but the fact that it has leaked right through is, well, it's fantastic. It's just fantastic. So I'm not going to muck around with trying to clean this anymore for the moment. The next step is to drop it into the ultrasonic for a really good solid wash, and then I'll take it out and see what sort of state it's in, and probably make a decision as to whether it's even worth fixing. Okay, so here is our Mac Classic board after an ultrasonic clean, and it has revealed a few problems. So this is the real-time clock chip, and this one was absolutely caked in corrosion, and as you can see, that corrosion has eaten right through, and we're missing a leg here from the chip, and we're missing a leg here, and obviously these legs here as well, they're in pretty average condition. There's probably more corrosion than there is metal. So that's one thing. This chip here, look, I could probably do a repair in here, you know, sort of chip away at that enough to get a little knob of solder on it and run it down to the pad, but I'm not sure how reliable that would end up being. It would be very easy for it to come off. If we look over here, you can see there's the pad, and there's a great big gap here where there should be a trace. Again, can be repaired. Same here. got a gap there. So I would think this chip would have to come off, and I would think that pretty much every one of these pads will need to be checked, and probably a lot of them will need to be redone. Here's another gap in a trace here. That trace is actually just rusted all the way out, so there's a break in that there. Again, traces can be repaired, but it is a bit of a mess. This here is a little switching diode. Now this would have to probably be replaced. I mean, there's a lot of rust there. And as you can see, this one here is rusted so badly it's actually fallen off. These are still readily available, very cheap to buy, no problem replacing those. Assuming we go down the path of actually replacing this, well, this would have to be sourced. I don't believe this is still readily available, so this would probably either have to come off another board, a busted board, or perhaps salvage it. This same clock chip may well be on other boards. We might be able to find it elsewhere. This is obviously where the capacitor's fallen off, no problem. I mean, the capacitor is, you know, sort of, all capacitors would have to be replaced anyway. There's still quite a bit of corrosion around here, but, you know, again, I think these ones would probably still have continuity. Up here is underneath the battery holder. Now what you're seeing here is one solid clump of rust, a rock hard clump of rust. Now this should actually connect to this plane here. This is all part of, I'm pretty sure this is all the ground plane here. No problem linking a connection there, but the fear is that all of this rust inside could well have expanded into other traces within this board and could be causing a short. First time power gets run to this whole thing could just start smoking and pop and do all sorts of horrible things. Unknown, really. It is possible that would still work, but I'm not really sure. This here is the top of there, which goes through, I'm just going to flip the board over, goes through to this point here. So the rust is on the other side of that. So it's connecting that on the outside down onto this here. All three of these would need to be replaced. Again, very readily available. I think they're 100 kilo ohms, something like that. All of these would need to be replaced. These should be replaced probably as well. Then let's have a look here at these. We've also got these. These are vias that go from here through to the other side. They've lost all the coating. The traces have all busted. Relatively easy to replace these. Just run wires, poke them through the bottom, and then hook them up to whatever they're meant to be hooked up to on the other side. That's okay. So there's those. We've got another one here. That's for the battery holder, I think, from memory. Yeah, so that's the negative of the battery there. That's the positive of the battery there. Again, trace completely gone here, but that can be replaced. What else do we have? We've got these rings here. They're gone. They would all need to be reconnected to these little traces. Okay, if you see this cloudiness going on inside here, now that's corrosion inside a layer inside this board. Now that of course could just be doing all sorts of things inside that layer, creating shorts or or no connection at all. So that's a real concern, what you're seeing inside here, this sort of cloudiness going on around here. So that's my thought, is that there is the potential to invest several hours of time and cost for parts and end up at the end with something that still doesn't work. I would probably be more inclined to put this board to one side and all the other parts of this computer and reserve them as parts for potentially repairing something else, another sort of Mac Classic, because I just believe that this one is probably a little bit too far gone. But there are still quite a few functional components on it, and you know, sort of, and so for that reason, it may end up being able to give its life for a different computer at some stage in the future. And that's pretty much my assessment. So there you go. Right, well, the decision has been made that this board is not going to get repaired, and I think it's a good decision because I think the potential of it actually working again are very low, especially when compared with the amount of work that would need to go in to get it even to a state where I would even half think about putting power into it. But just for the sake of making the end of the video a little bit more interesting, I thought I would just sort of demonstrate a process, and I am going to actually demonstrate doing a trace repair. When I'm doing a trace repair, I use wire like this sort of enameled wire that you would use for a transformer or an electromagnet. It's because it has a coating on it, it is insulated, so if you're attaching it across the board, you know, it's you don't have to worry about the wire touching other contacts on the board. But having said that, that coating comes off very easily with the heat of a soldering iron. So when you actually need to get that coating off for making a join, it's actually quite easy to do. So I've got this stuff in various thicknesses, and I use a thickness relative to the size of the trace I'm going to be repairing. So I'm going to be using this wire. Now I've also obviously got my microscope here, and I would not even consider doing this sort of work without a microscope, one with room underneath it for you to be able to work with your hands, and obviously, you know, reasonable quality soldering iron, you know, good quality solder, and loads of flux. So anyhow, I'm going to flip over to the view from the microscope now, and we will continue. Okay, so I'm going to start with this trace repair, which I'm only using this as a demonstration. In actual fact, this is busted up here. Yeah, it's busted up there. But what I'm going to do is I'm just going to show you how I would join from there to there. And that's just for the sake of the demonstration. So the first thing I do is I start off by exposing the copper at one end. Now, I'm using for this a scalpel blade. Now, you could use like a craft knife, but I prefer these particular scalpel blades because these have this curved edge. There you go. They're Swan Morton blades. They have this curved edge, and I find that really good for scraping. I just think it's wonderful. So I buy these. These are, you know, proper actual surgical scalpel blades. So be very careful with them because they are designed specifically for cutting skin. So if you're not careful with them, you can do yourself a real mischief. So I'm just going to start as improve the focus somewhat. There we go. That's a little bit better. Okay, so then I'm going to expose a little bit on this side as well. There we go. Now, so we've now got two areas of copper exposed on both ends, and then obviously the gap between the two there. So the next thing I'm going to do is plonk a little bit of flux on that copper, either end, grab my trusty soldering iron with quite a fine point on it, like that point there, and I'm going to put a little bit of solder on there. So now we've got some solder stuck on to that bit of copper that was exposed. There we go. It does occur to me that I probably should be doing this around this way. Don't you reckon? Yeah, probably better. Now, the thickness of the wire I'm going to be using is this stuff here. Truth be told, the thin stuff is actually a lot easier to use than thicker stuff. As you can see, it's comparable sort of thickness to this trace. And just to give you an idea, there's my great big fat chunky finger that gives you an idea of the scale of this, what we're actually working with here. So I'm going to start at one end of this wire, and I'm going to hold it down here and apply some heat to it. And this heat that I'm applying to it is going to be melting that coating off the wire, and as that coating comes off, it will then start to suck up some of that solder. Sometimes easier than others, sometimes easier than other times. As you can see, it's starting to adhere now. Now, if I take that away, you'll see that's actually stuck on now. Now we need to do the same at this side. Applying that heat. I'll just get a bit more solder on here, because the thing is that once the solder actually, if you've got a bit of a glob of solder on there, as it molds around, you're helping to actually disperse heat right over the whole wire as the solder wraps around it. Okay, just keep it going here. A little bit of movement here to help get that coating off. There we go, we can see that solder adhering now. Moving up, moving up, moving up. There we go. So what we want to see is we want to see the solder. I'm going to zoom right into this now. I want to see it going right over the sides of the wire, and then down to the copper underneath, which you can kind of see that there. Okay, so that's stuck on there quite well. There we go, just gonna, there we go, get a nice in focus shot of that for you there. Okay, so move back out now. Right, now we just need to cut the end of this wire off. Now, this wire, you can actually just bend it backwards and forwards and backwards and forwards and backwards and forwards, and it'll bend and it'll break by itself. Oh, how about that? How good is that? What sort of joint is that? That's some sort of special joint. Okay, I'm just going to put a little bit more solder under there. Sorry, flux under there. And we're going to do that again. Okay, that, now we're stuck on. Okay, so let us now break this off. There we go. Basically just bending it backwards and forwards with just a little bit of help from the scalpel. So, now, that's stuck on at that end, that's stuck on at that end, and that is one successful join. I'm just going to clean it up a little bit, because it'll, with all this flux around it, it's a bit hard to see. But there you can see we've got a nice trace join. Now, of course, doing let's dry it up a bit. That's basically what's involved for any of those joins. It could, of course, be a very, very slow and tedious process, but that's basically what's involved. Now, I'm going to do another one now, but this time I'm going to do one that goes through the hole and onto the other side. So once again, we've got to start by exposing some copper here. So just expose that copper. Now, I think the safest way to do it would be to actually poke it through the hole first. So I'm going to do that now, and my goodness, I am going blind. Right, so there we go, a little bit of wire poked through the hole. So what we need to do now is, well, I have jumped a step, haven't I? I've got to put some solder onto this first. Like so. Yeah, look at that. Nice big chunk of solder. Now, the next thing I'm going to do is try and get this wire so that it kind of fits that shape. I've got a couple of pairs of tweezers here. There we go. Now this is a part of the process where it's really nice to have 3 hands. But you know, unfortunately I don't actually have 3. I've only got 2. And they're not even the steadiest ones around either. So once again, applying the heat to this wire to get rid of that coating. See, it's starting to come off now. And we get that all looking like it's stuck on. Okay, it does look like it's stuck on, but you know, I've got a mantra. Put more flux on it, try again. Okay, let's try that again. Okay, I'm pretty confident about that. That seems pretty well stuck on. I do apologise when I apply a bit of weight to the table, it goes out of focus as I push it. Okay, so let's just trim the end of this off. I didn't make him very long, so I've only got a bit of extra here. Be of course very careful with the scalpel on a board like this, because you can end up doing a lot of damage. So we've got that through. Now this via is completely and totally shot, all the way through. So I'm going to then use this wire instead of the via. Now one thing you do have to remember, of course, is vias don't always just go from the top to the bottom. Sometimes vias actually send to a layer in the middle, because there are lots of layers inside this. But I am assuming, for the sake of the repair that I'm doing here, that this via just goes from the outside, from this side, right through onto the other side. Right. Now we're going to have a little bit of a change of focus here, because we're a little bit higher. Let me just get this out of the way. Cramping my style here. There we go. Alright, so here's my little hole. There's my little wire poking through. So let's just once again expose some copper. A lot of copper here. Come on, where am I going to find some copper? There we go. Well, look at how much of that copper is gone from here all the way along there. So we're going to take this right up to this point here. Now, of course, if you're doing any sort of repair like this, once it's finished, once it's done, cleaned, ready to go, it's really important you got to put some conformal coating on it. And it's basically this goop. I've got some around here somewhere. This green goop. There are clear ones as well, and you pour it on and it just coats over the surface. You expose it to UV light, which dries it, and it essentially creates like this green coating that you see here. It coats over top, just holds the wires in place, much less likely to get damaged or fall off in the future. Alright, so here's my little wire. Once again, I'm kind of just trying to get him to sit in a position somewhat like how that trace is, just for the sake of aesthetics. And let's get some solder onto there. Okay, so that copper is now tinned, and then we do the same with the wire. Rubbing backwards and forwards, getting that coating off. You sort of feel the coating kind of give way after a while. It starts off when you're rubbing the wire, it's really smooth, and then it starts to get rough. As it gets rough, you know you're actually getting through that coating and into the wire underneath. Okay, holding that in position. Okay, and that, my friends, is that. Just focusing again. I do apologise for the change in focus of this all the time. It's because the board is actually moving a little bit. Okay, again, this comes off. Yeah, come on. There we go. Right, so that's, we've got that join there, going through to the other. Now, if anyone wants to doubt me, there's that point there. I just need to, I was thinking what I might do is just demonstrate that we do actually have continuity. So that one there, I've got that hole there, it's 1, 2, the third one along. So where's our hole? There's our hole. Was it 1, 2, 3? I think so. It's that one there going to there. So let's just test a theory. Oh, so we're not testing theory at all, actually. Testing my work. Okay. Right, so get our multimeter, which you'll just have to take my word for it. That's what I'm doing at the moment, getting my multimeter. I'm putting it on to make a noise when it's when there's continuity. Put that nearest to the microphone so you can hear it. So what did I say? It was the, which one was it? 1, 2, 3. This one here. Yay! And then if we follow this one all the way down to oh bloody hell, how far are we following this one? There to there. We go from there, and I just have to take my word for it. I go up here to this one. There we go. And so I've actually been able to restore continuity by repairing that little trace. So as I say, that's how I do trace repair. Other people might do it differently, but that's how I do it, and I find it works quite well. Okay, so there's the trace repair, and as I mentioned before, I have this conformal coating that I can put on. Conformal meaning it conforms to the shape underneath it. Let me just grab it. So here's the stuff. It's just this stuff that comes in a tube, and it's green and it's gross, and that's it there. And basically I'm just going to squeeze some of this onto the surface. Okay, so I've put a little bit of that conformal coating onto the trace repair that I've just done, and I'm just dabbing it around here with a cotton bud. You can see the trace underneath it. I've got perhaps a little bit more on here than I needed. You only need to be pretty sparing with this stuff. You can do it in layers. You can put the first layer down, dry it, and then put another layer on top. But just basically put that on there, and the next thing I do is shine a UV light on it, which you can't see through this microscope. So perhaps if I change cameras. Okay, so now I'm going to move the microscope out of the way, and we'll put that there. And if you have a look here, I've got a globe here with a UV light in it, and I just basically hang that over top and let that bake, and that UV light will make that that coating go hard, and then that will help protect the trace repair. And so if you are doing a trace repair, I would highly recommend putting a coating on top of it once you're finished. And that's that. Okay, so here is the conformal coating after a few minutes under the UV light, and as you can see, it goes quite hard. This is now a pretty solid sort of substance on top of this, and of course provides excellent protection for any little repairs you have like this. So if there are any bumps or knocks or anything like that, you're not going to end up with one of these little trace repairs just falling off. So with any sort of trace repair like that, make sure you do put a coating on it afterwards, because that will improve the chances of it working, you know, sort of staying functional. Okay, that's that.